Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, we are focusing on one of the factors that influence the reaction rate. And that factor is state of division, or sometimes known as the surface area. Are you together? Please note that guys, each and every factor will have its own video because I want to explain thoroughly in each and every video. Okay. We are told that learners used two experiments to investigate the influence of surface area or states of division on reaction rates. Now, the balance equation is as follows. In both experiments, learners used 10 grams of calcium carbonate solid. The conditions of two experiments are given in the table below. And then we are told that our hydrochloric acid is in excess. Okay. So that means the calcium carbonate is our limiting reagent. Guys, what is a limiting reagent? A limiting reagent is a reagent that will be used up completely in a reaction, or you can simply say is the reagent that determines the progress of our chemical reaction. Okay, for experiment 1, okay, in both experiments the temperature is kept the same. The concentration of our excess hydrochloric acid is kept the same. However, the states of division is not the same. In experiment 1, our calcium carbonate is in powder form, and in experiment 2, our calcium carbonate is in solid form. Are you together? So please note that guys, the one that is always in powder form will simply have the highest rates of reaction. So the one that is in powder form will simply have the highest rates of reaction. Eh? Why is that the case? Because whenever guys you change your solid into powder form, you are exposing the particles that are supposed to collide. Are you together? So now it will be quicker for us to form effective collisions. Are you together? Excuse me. It will be quicker for us to form effective collisions. So and then now we are being asked, use the collision theory to explain which experiment will have a higher reaction rate. Experiment 1 will simply have a higher reaction rate. And why is that the case? Because whenever they use powder instead of solid, they are increasing the surface area, or they are increasing the states of division. An increase in surface area will lead to particles being exposed to form effective collisions, or rather to collide with other reactants to form effective collisions. More particles will be exposed to collide, and hence there will be more effective collisions in a short space of time. Are you together? And obviously guys, if remember that rate of reaction, ROR, is basically the change in quantity of your product or reactant all over the change in time. If you are decreasing the amount of time it takes for your particles to collide, you are obviously increasing the reaction rate. That's why whenever you increase the surface area, you end up having a higher rate of reaction. And therefore, the rate of reaction will increase. Are you together? An increase in the surface area of our solid will lead into particles being exposed to collide. And since particles are being exposed to collide, we'll end up forming more effective collisions in a shorter space of time. and then that will lead us to having a greater rate of reaction. Okay. The graph, the sketch below shows the decomposition of calcium carbonate over time. Which curve represents experiment 1? Remember that, guys, experiment 1 is the one that takes place whenever the calcium carbonate is in powder form. That simply means that experiment 1 will reach completion faster. Are you together? So it will simply take 4 minutes for curve 1 to reach completion, and it will take 9 minutes for the second one to reach completion. Why does it take longer? Because the particles that are supposed to collide of our calcium carbonate are not exposed. Are you together? So the one that represents experiment 1 is basically curve P. There's curve P and curve Q, right? Curve P will simply represent experiment 1. Okay, and then now we are supposed to calculate the rates of reaction in the experiment, or in experiment 2, and our rate of reaction should be in moles per second. Okay, I know the initial mass of my calcium carbonate, né? That was 10, and since my since I was told initially that the hydrochloric acid is in excess, that simply means that my calcium carbonate will be used up completely. Are you together? So it will take 9 minutes for the calcium carbonate to be used up completely in experiment 2. Okay, remember that, guys, the rate of reaction is always the change in quantity all over the change in time. In this case, they want us to find the rate of reaction in mole per second. That means you must find the change in the number of moles of our calcium carbonate that changes per unit time. How can I find the number of moles of calcium carbonate? I know that N is equal to mass all over the relative atomic mass number. The initial mass, it was just 10 grams. Then the relative atomic mass number, calcium, I have 40. Remember that, guys, it's calcium carbonate. So calcium has 40 grams per moles. Carbon has 12 grams per moles. Oxygen has 16, but I have 3 oxygens. So this will basically give me 10 all divided by 40 plus 12 plus 16 times 3. And that will give me the number of moles to be 0.1 mole. So our calcium carbonate had 0.1 moles, guys, né? And it was and this 0.1 moles, they got used up completely in 4 minutes for experiment 1, and they got used up completely in 9 minutes for experiment 2, né? So the change, the reacted moles is basically going to be the initial number of moles, 0.1, minus the final number of moles, né? Finally, I had 0 left because calcium carbonate was my limiting reagent. So I didn't have any amount left, né? Okay, and then obviously the amount of time it took, it was 9 minutes. So I'm supposed to change the 9 minutes to be in seconds, since I'm supposed to find the rate of reaction in moles per second. I'm just going to say 9 multiplied by 60, and then I'll simply get 0.1 minus 0 all over 9 times 60. And that's, let me make sure my calculator is in scientific mode. This will simply give me 1.83, or rather 1.85 times 10 to the power negative 4 mole per second. That's how, guys, we're supposed to deal with acceleration. Yeah? Why did I say acceleration? But the rate of reaction. But the most important part, guys, was just predicting by using collision theory. Yeah? And yes, I know that this is always there. These 5 marks, 4 marks questions are always there for you to calculate the rate of reaction. So, guys, please, guys, do stay tuned and wait for more videos. And yes, there will be exam videos, exam-like questions that will be posted after this video. And it's just 11 questions, ne? And all of these questions, guys, are extracted from exam past papers. I believe it's very important for you to tackle such questions. So please, guys, do watch those videos, ne? So that you'll have an edge whenever you write your final exam. Yeah, that's how, guys, you're supposed to deal with this thing. State of division or surface area. So just stay tuned, guys, and wait for more videos. Thank you.